P. Jansi Nikita, BTech second year ECE B section. My topic about expectation. Let's see expectation. Expectation. Definition of expectation. The mathematical expectation or expected value of a random variable x is the mean or average value of its probability of distribution. Expectation means mean or average value of the probability distribution. It represents long-term average outcome if an experiment is repeated many times. It is denoted as x bar or E of x. Expectation is denoted as x bar or E of x. Mathematically, it is weighted average of all possible values that a random variable can take where weights are their probabilities. Simply, we can say expectation of probability distribution is x bar of or E of x. Next, expected value for a continuous random variable. If x is continuous random variable with a valid probability density function, it is denoted as E of x equal to integral minus infinity to infinity x into f of x fx of x dx. Here x equal to value of the random variable f of x, fx of x equal to probability density function of x. It is similar to a continuous random variable for density function e of, but small difference is there e of x function. Next we can see discrete random variable. If x is a discrete random variable with possible values x1, x2, x3 and so on xn and corresponding probabilities p of x1, p of x2 and so on p of xn, let E of x equal to summation I equal to 1 to n xi into p of xi, where xi equal to ith possible value of the variable, p of xi equal to probability of xi, n is the finite or infinite values. Expected value for discrete random variable of a function. Next, if values are equally likely, we can say special case equiprobable outcomes are there. P of x1 equal to P of x2 equal to and so on P of xn equal to 1 by n. Then E of x function E of x equal to 1 by n into x1 plus x2 plus and so on plus n. This is simply the arithmetic mean of all possible values. Next, some problem. Find the expected value of a uniformly distributed random variable. Let f of x equal to integ 1 by b minus a less than x less than b, 0 otherwise, where a comma b are real constants. Formula for continuous random variable of expected value of a function e of x equal to integral minus infinity to infinity x f of x dx fx of x dx. Then e of x equal to 1 by b minus a. Here limits are a b. Integral a to b x by b minus a dx. Take outside on 1 by b minus a constant into x integration x square by 2 of a integral a to b equal to substitute these values a to b square minus a square by 2 into b minus a equal to a plus b by 2. The mean value of x is e of x equal to a plus b by 2. This is for uniformly distributed random variable. Next we can see expected value of function of a random variable. Sometimes we are not directly interested in the expected value of a random variable x, but in the expected value of some function x comma written as g of x. G of x is a function of random variable, can be any real function of x. Examples: x square sin x, e power x, etc. This is useful in calculating measures like variance, moments, and mean square values. This is also two types of random variables: continuous random variable and discrete random variable. First, we have to see continuous random variable e of g of x. It is also similar to expectation value, but small difference: g of x is there. E of g of x equal to integral minus infinity to infinity g of x fx of x dx. This formula finds the weighted average of g of x over all possible values of x. Next, discrete random variable with values x1, x2, and so on xn. It is similar to expected value of a function, but small difference is that g of x function and corresponding probabilities p of x1 comma x2 and so on p of xn. Next, formula for discrete random variable e of g of x equal to summation I equal to 1 to n g of xi into p of xi. Here we multiply each function value g of xi by its probability and sum of overall all possibilities. Next we can see conditional expectation of a random variable. Conditional expectation is the expected value of x when we already know that some event b has occurred. Already b event has occurred, its answer given that have some extra information event b. What is the expected value of x? If event b has occurred, but find out expectation value of x. If the conditional probability density function of x is given b, fx of x by b, then function expectation of conditional random variable e of x by b equal to integral minus infinity to infinity x into fx of x by b into dx. This is similar to expectation, but small difference is there. By b is difference because of conditional expectation of a random variable. Next we can see special case of event based on x. If the event b depends on x such that b equal to x less than or equal to b, meaning of x is known to be less than or equal to b, then conditional PDF is fx of x by x less than or b equal to fx of x by integral minus infinity to b fx of x dx x less than b 0 otherwise. Conditional expectation becomes e of x capital X by capital X less than or b equal to integral minus infinity to b x f of fx of x dx by integral minus infinity to b fx of x dx. This formula gives the average value of x when we know it does not exceed b. Means x is less than the b. Exceeds b is not exceed when compared to x. We can say next. Properties of expectation. One by one we can see. First property, expectation of a constant. If A is constant, E of A equal to A. Expectation means E of X. If X is constant of A equal to A. If in case, discrete case, E of A equal to summation X into A into P of X equal to, if A is constant, that's why taken outside A summation X P of X equal to P of X means 1. Substitute P of X A into 1 equal to A. If in case, continuous case, E of A equal to integral minus infinity to infinity A into F of X dx equal to A constant. That's why I am taking outside A of A integral minus infinity to infinity fx of dx equal to A into 1 equal to A. Next property. Multiplying a random variable by a constant. If A is a constant, E of A